The next example is trace a square y square is equal to x square into bracket a square minus x square. Now trace this curve. Again we have to go through 6 points. The first one is symmetry, second is origin, third is points other than origin, fourth is asymptote, fifth is region of absence, and last part it is shape of the curve. So the first point it is symmetry. So in symmetry, as equation of curve contains even and only one power of x as well as even and only one power of y, and therefore this curve is symmetric about y-axis and this curve is symmetric about x-axis. So given curve is symmetric about both axes. Given curve is symmetric about both axes. Now after symmetry, we will check whether curve passes through origin or not. To check origin, put x is equal to 0, y is equal to 0 in the given equation. So put x is equal to 0, y is equal to 0. Then LHS is 0, RHS is 0, and therefore equation of curve gets satisfied, and thus this curve passes through origin. So given curve passes through origin. Given curve passes through origin. Now once curve passes through origin, the next work is to calculate equation of tangent at origin. And how to calculate equation of tangent at origin? We equate the lowest degree term to 0. So to get tangent at origin, equate the lowest degree term from the given equation to 0. Now we will consider the equation, that is a square y square is equal to a square x square minus x raised to 4. So here degree is 2. For this term degree is 2. Here degree is 4. So there are two terms having this degree, and therefore equate these two terms to 0. We get a square y square minus a square x square equal to 0. And this implies y square minus x square is equal to 0. Implies y square is equal to x square, and this is nothing but y is equal to plus or minus x. So what it means? At origin there are two tangents, y is equal to x and y is equal to minus x, and these two tangents are real and distinct, and therefore origin is unknown. Origin is unknown. Okay. Now the third point is points other than origin. In this point, what we do? We find the points of intersection for the given curve other than origin. Now to get point of intersection on x-axis, put y equal to 0. To get point of intersection on x-axis, put y is equal to 0. And when y is 0, then this equation will become x square into a square minus x square is equal to 0. So this implies x square is equal to 0 and a square minus x square is equal to 0, and therefore x is equal to 0, and here a square is minus x square is equal to 0, implies x is equal to plus or minus a. So by putting y0, we got x0, xa and x minus a. So a0 and minus a0 are the points with x-axis. A0 and minus a0 are the points with x-axis. Now to get point on y-axis, what we do? We substitute x is equal to 0 in the given equation. Where x is 0, RHS is 0, and therefore a square y square is equal to 0. This implies y square is equal to 0 implies y is equal to 0. It means origin is the only point with y-axis. Origin is the only point with y-axis. There is no point other than origin on y-axis. Now, points other than origin are a0 and minus a0. Now, the next work is to calculate equation of tangent at a0 and minus a0. To get tangent at a0 and minus a0, we are having two methods. Either we use shift of origin or calculation of derivative at a particular point. Now what we will do, in first point we use shift of origin, and for second point we use the method of calculating derivative at this point. So to get tangent at a comma 0, we use shift of origin. Therefore the transformations are x is x plus a and y is y plus 0. So replace these values in the given equation. We get a square y square is equal to x plus a bracket square in bracket a square minus x plus a bracket square. So if I simplify, I will get a square y square is equal to x square plus 2ax plus a square. This is in first bracket, and second bracket it is a square and minus a square will get cancelled. So a square minus in bracket x square plus 2ax plus a square. Now this is nothing but a square y square is equal to x square plus 2ax plus a square. It is in one bracket. Here a square will get cancelled. What is remaining? Minus into x square plus 2ax. Now after shift of origin, to get tangent at new origin, equate the lowest degree term from this equation to 0. Now here degree is 2. After multiplication with x square, degree is 4. Here degree is 3. Here degree is 2. And if I multiply second term, that is 2ax, to all the terms inside this bracket, then degree 3, degree 2, and this is the only term having degree 1. So equating lowest degree term to 0, we get minus 2a into x is equal to 0, and this implies x is equal to 0. But what is value of x? It is x minus a is equal to 0, and therefore x is equal to a is the equation of tangent at a comma 0. Now actually, as curve is symmetric about y-axis, it is not necessary to calculate equation of tangent at minus a comma 0, because whatever tangent is there at a0, the same or the parallel line will be tangent at minus a comma 0. But still we calculate tangent at minus a comma 0 by using calculating derivatives. Now to get tangent at minus a comma 0, we will calculate dy by dx. So given equation is a square y square is equal to x square into a square minus x square. Now if if I differentiate this equation with respect to x, I will get 2a square y dy by dx is equal to d by dx of this x square into a square minus x square. Isn't it? Now, therefore, dy by dx is equal to d by dx of x square into bracket a square minus x square divided by 2a square y. Now, if I calculate the value of dy by dx at minus a comma 0, what it means? Value of dy by dx at x is minus a and y is 0. And when y is 0, this denominator is 0. If denominator is 0, then value of dy by dx is infinity. And if dy by dx at a particular point is infinity, it means tangent at minus a comma 0 is parallel to y-axis. Parallel to y-axis. Okay. Now we will proceed further for the point asymptote. So how to calculate asymptote? Again, there are two methods. One is find the highest power of x, find highest power of y, and then check their coefficients. So here equation of curve is a square y square is equal to x square into a square minus x square. Now here highest power of y, it is y square. What is its coefficient? It is a constant, and therefore asymptote parallel to y-axis is absent. Now if I see the highest power of x, here x square into x square is x raised to 4. This is the highest power of x, but its coefficient is minus 1 and that is constant, and therefore asymptote parallel to both the axes, asymptote parallel to both axes are absent. Asymptotes parallel to both axes are absent. Okay. Now the next point to trace the curve, it is region of absence. Region of absence. Now in region of absence, what we are going to check whether curve is present in a particular partition. How to develop the partitions? There is a procedure. What is the procedure? First, plot the points of intersection. So what I will do? I will draw coordinate system. So the points of intersections are origin, one point, A0 it is second point, minus A0 it is third point. So first plot the points of intersection. So here I will write it as A0, this is 0, 0 and this is minus A comma 0. After plotting the points, if asymptote is present, then asymptote itself is one of the partition. But for the given curve, just now we have seen there is no asymptote parallel to both the axes. Now, do the partitions. How we do the partitions? We draw the line through these points, either parallel to x-axis or parallel to y-axis. But here the points are on x-axis. Therefore, we have drawn the partitions parallel to y-axis. So, total 4 partitions we will get. This is first, this is second, now this is third, and this is fourth. Now, after doing the partitions, the next work is define the partition. How we define? Here, this point is 0, 0. This point is A0, therefore this partition is 0 less than x less than a. This partition is x greater than a. This partition minus a less than x less than 0. And the first partition it is x less than minus a. Now we have to check whether curve present in these four partitions. But as given curve is symmetric about both axes, it means curve is symmetric about y-axis. So as curve is symmetric about y-axis, it is not necessary to check the curve in third and fourth partition. Only we are going to assess it in first and second. By symmetry, we can decide whether it is present in third or fourth. Okay. Now to check whether curve present in first partition, choose the value of x. Now here as x less than minus a, choose x is equal to minus 2a. Now after choosing x is equal to minus 2a, what is the equation? It is a square y square is equal to x square into bracket a square minus x square. Now what is the value of y square? It is x square into bracket a square minus x square divided by a square. Now when x is minus 2a, this is positive. This is positive. But when x is minus 2a, so this will be a square minus 4a square. So a square minus 4a square, it is minus 3a square. It means this is a negative. So y square less than 0 and therefore curve is absent. Now as curve is absent in first partition, by symmetry it must be absent in fourth partition. Okay. Now we will check whether curve is present in second partition. To check, put x is equal to minus a by 2. This is the point in this range. So x is equal to minus a by 2. When x is minus a by 2, this is positive. But here a square minus a square by 4. A square minus a square by 4, it is 3a square by 4. This is positive and therefore y square positive, curve is present in second partition. But as curve is symmetric about y-axis, it must be present in third partition. Is it understood? Now we will move towards shape of the curve. So the last point, it is shape of the curve. Now while tracing the curve, first we draw coordinate system. So this is x-axis and y-axis. The first point symmetry we will see at the last. The second point origin, yes, for the given curve origin is present. At origin, what is the equation of tangent? Just now we have seen at origin the tangent is y is equal to x with this line and y is equal to minus x with this line. Okay. So in second point already we have decided at origin there are two tangents, that is y is equal to x and y is equal to minus x, and which are real and distinct, and therefore this origin it is called node. Now third point, points other than origin. Yes, there are 2 points other than origin. So I will denote that point, it is a0, and again one more point, it is minus a0. Now at these 2 points already we have calculated equation of tangent. At a0 the line x is equal to a is tangent at a0, and similarly the line x is equal to minus a is tangent at minus a0. Okay. Now these two lines are tangent at a0 and at minus a0. Now as these two lines are tangent at these points, at a0 this line is tangent, therefore the curve have shape either on this side or on this side, but after a0 curve is absent, and therefore I will remove this part. So curve is absent in fourth partition. Similarly, at minus a0 this line is tangent, so possible curves are either on this side or it will be on this side, but before minus h0, curve is absent, and therefore I will remove this part. Okay. Now this y equal to x is a tangent at origin. This line y equal to minus x is a tangent at origin. Therefore, here the shape will be like this. On this side, again on this side. As this line is tangent at origin, the shape will be either on this side or it will be on this side, isn't it? But the part of the curve lies here, therefore we will extend this part of the curve toward this side. Okay. And again we will extend this part towards this side. Here also we will extend these two parts. So this is the curve, and again this is the curve. As there is no part of the curve lies here, so we will remove these two. Okay. So this is final shape of the curve. Now this origin here it is unknown. Okay. And these are the points of intersection, that is a0 and minus a0. So this is final shape of the curve. Okay.